Hello, this is Mr. A again with another solved problem. This problem is about optics and the power of lenses. So let's go ahead and read the question. A human with bad vision is reading a book which is 14 centimeters from the eyes. He needs glasses with what optical power if recommended reading distance for healthy humans is 25 centimeters? Okay, so here we have a situation where somebody's trying to read a book. They're holding it at 14 centimeters from their eyes because that is what their eyes can see. The best place or the best vision or the best focus is available at 14 centimeters. However, since the recommended distance is 25 centimeters, that is where the eye is most comfortable. So, in other words, when they are trying to read something with holding it 14 centimeters from their eyes, it strains the eye. So they want the eye to be able to see from a distance that is comfortable, and for that they need corrective lenses. Okay, so the question is asking what should the power of the lens be so that the correction is such that the image is formed at a location from where the eye can see comfortably. That is basically the idea. Okay, first of all, it's important to convert units to SI. And that is one thing that we must almost always do because when there are units that are formed by a combination of uh, some units, then it becomes complicated if you don't convert them first. And in this case, the unit that our answer is going to be in will be diopter because that is the unit for power. However, that translates to a focal length measured in meters. And if we want to find a focal length in meters, then our image and object distances should be in meters so that everything works out smoothly. Okay, so basically that's really all there is to this question, but we'll go ahead and solve it. So our image distance is uh, negative 0.25 meters. And why is it negative? I'm going to explain that in just a moment. The object distance is 0.14 meters, not centimeters, sorry about that. Because it's 14 centimeters, so it's 0.14 meters. Now, when somebody reads a book, they want to be able to see the book right side up. All real images are inverted. And therefore, if they are going to see the book right side up in the image, or the image will be right side up, then it has to be a virtual image. There are other explanations for that also, but that is the simplest answer at this point. Because they want to read it right side up, they want the image to be right side up, and therefore the image has to be virtual. If the image is virtual, then the image distance is also virtual or negative. Okay, so we take the image distance to be negative 0.25 meters. That is where the image should be for the eye to see comfortably. All right, and then object distance, that's where the book is being held at 0.14 meters. And then basically we use the uh, thin lens formula, 1 over f equals 1 over v naught plus 1 over vi. It's not v naught, sorry, it's vo. 1 upon VO over 1 over VI. This terminology could be different in different books and different systems. I mean, it doesn't matter. The idea is that F is the focal length, VO is the object distance, and VI is the image distance. Okay, and then we just plug the values in. So 1 upon F becomes 1 upon 0.14 plus a negative 1 over 0.25, and the answer comes out to 3.14 diopter. Okay, something that needs to be clarified. A diopter is, or the power of a lens is the reciprocal of the focal length. According to this formula, we first find the reciprocal of the focal length, and then if you need the focal length, you take 1 over f, and that gives you f. In this case, because we are actually looking for 1 over f, which is the power, there's no need to do a reciprocal. The answer itself, the 1 upon f, is your answer, and that comes out to 3.14. So the power of the lens that is required is 3.14 diopter. And I mean, if you want to round it off to whole numbers, then it would be 3 diopters. But the reason, remember, that we converted to meters is because diopter is connected to focal length, where the focal length is measured in meters. Unless we have a focal length in meters, this answer will not be in diopter. It will be in some other unit. And we're not going to go into that detail at this point, but keep in mind that in most cases, not just in this situation, in most cases, it is a good idea to convert units to SI. That makes life a lot simpler and things come out much more correctly. Okay, so that's basically all there is to it. And I have a little note here for everybody. If you have any further questions or clarifications that you need on this, uh, please go ahead and send me a message. And if you are looking for a one-on-one tutoring, uh, again, you can get in touch with me both on the Wisent platform. All right, thank you very much. This is Mr. A signing off.